Mark Heckler, and I'll be your tech fashion tour guide for the next few moments. Guess I could start that. As we explore the good, the bad, the what might have been, and the what might yet be. So, there's a saying that fashion is fleeting. I keep turning. I need to probably stop that. I'll just try to look straight ahead and into the lights. There's a saying that fashion is fleeting, but style endures. We developers like to think of ourselves as rational, data-driven problem solvers, but let's be honest, we also love looking good. And as developers, looking good means using the latest, greatest tech. So here's the ugly truth. Technology trends are often driven by fashion as much as by function. You want to know a secret? It's okay. Yeah. Oh, thank you. Okay, only one person gets to... Oh, no, I'm just kidding. I'm dressed reasonably well today, right? Oh, yeah. Oh, good. I mean, for me, this is really amazingly well. But anyway, but I am wearing at least two examples of faded fashion right now. I'm giving away my secrets here. So let's start with this pocket. Right here. And let me tap that. So there. Yeah, I have to look over and see where it is. There we go. So it's small and often overlooked. It doesn't seem to really serve a purpose, but it did at one time. And that function quickly became fashion. One might call it style since it's lasted so long, but I leave that up to you. This lowly pocket's purpose was to hold a pocket watch. The watch pocket was first introduced by Levi Strauss & Company in 1873 as a feature in the original Levi's jeans. At the time, many men carried small pocket watches on chains, and cowboys, railroad workers, and miners needed a safe place to store their watches. Now, some of you may love retro expressions as much as I do, but I suspect I could count on one hand the number of folks here who are carrying a pocket watch. Maybe even one finger. Maybe even no fingers. I don't know. So what's up with that pocket? Over time, it's hung on, sometimes being used for other things like coins, matches, tickets, keys, lighters, even guitar picks. It may not have the same use case as initially intended, but for most people, but it has endured. And now you may never think of that lowly pocket the same way again. Bonus faded fashion, rivets. There we go, it's a little delayed, yeah. Most jeans are made with better seams and materials in 2025 than they were in 1873, at least you would hope. So rivets are mostly a superfluous flourish. And indeed, some denims don't have them anymore, but most do to this day. So let's move on to shirts. There's a loop that's often found right here. Right? So let me accent that. There we go. That's probably easier to see anyway. Guess what it's used for now? Yeah, well, maybe. Wow. Who said that? I'm really worried now. Can security? Anyone? Okay. Anyway, mostly today it's used for, well, nothing really. But such was not always the case for the infamous locker loop. The locker loop has an interesting history rooted in Ivy League fashion, practicality, and even romance. Yeah, oh, I heard the ooh. Who did that? Ooh. I think that was an ooh, not a ooh. I don't know, we'll see. Yeah, woo, all right, great. The locker loop is often credited to Gant, an American shirt maker, which introduced it in the 1950s. It was designed for college students and professionals to hang their shirts in gym lockers without getting wrinkled, hence the name locker loop. Many locker rooms lacked hangers, and lockers were small anyway. In the 1950s, the men needed a way to keep their shirt neat. In the 50s and 60s, the loop became a status symbol in Ivy League schools like Harvard, Princeton, and Yale. Students who wore Gant shirts with locker loops were seen as fashionable and well-dressed. See? Fashionable and well-dressed. Okay, thanks for humoring me. Now, here is where things take a strange turn. In the 1960s, it became a dating tradition for men at Ivy League schools to remove their locker loops if they were taken, signaling that they were in a committed relationship. It gets better. In some cases, girls would tear off the loop from a boy's shirt to express their interest or to claim them. Yeah, that's pretty brutal, right? You've heard the 60s were a weird time? Apparently so, yeah. The one part of fuzzy trivia about this is the question if the locker loop actually originated in the military, particularly the Navy, or if they simply adopted it after the loop gained traction. Either way, it served as a useful accoutrement with the tight quarters on a ship and the limited storage space. So today, the locker loop can be found on some dress shirts and absent from others, typically shirts with button-down collars. Fashion only, no real utility unless you still have a locker. Bonus faded fad, this button that appears on the back of some collars. Very few collars, but it still shows up from time to time. It was made to hold a necktie in place. But really, when was the last time you saw a necktie just fly off on its own? I don't know. It just seems odd, but here we are. So, yes, I was waiting. Technology as fashion. All right. So how much time do we have again? Here are a few of my favorite tech entries in no particular order. I had to eliminate a lot, as you might imagine, a lot of other contenders just to get down to this smaller list. So some we'll be reviewing today were bad, honestly. Some just had bad timing. Some evolved into truly useful additions to the software development landscape. And others still gained traction, but didn't have the reach initially expected. So, thank you. All right. Wow, are you guys sleepy? Okay. Was there still coffee in the hallway? I didn't notice. Okay, anyway. An early worry for developers was impedance mismatch between code and data, especially when said data was stored in third normal form in SQL databases. I'm still speaking English, right? Anybody normalized to third normal form? Yeah, okay, a few good database hands here. All right. The promise, the data structures underneath would align perfectly with your code, and as such, it would eliminate mapping and thus eliminate the impedance mismatch headaches entirely. The reality was that while the code looked better, the performance didn't. Even then, SQL was an established technology present in powerhouse relational databases, and SQL database performance absolutely crushed object database performance. Sometime later, NoSQL databases, particularly things like document DBs, wide table, graph databases, and other such constructs, similar enough constructs, they came on the market, and simultaneously, libraries and abstractions got better. And the promise of object databases has largely been fulfilled, even if the names have changed. Oh, that's a good one, right? Whew. The waterfall model, or method, if you prefer, was a linear and sequential approach to software development, because software development is nothing if not linear and sequential. Seemed like a good idea at the time, I suppose. Its goal was to provide a repeatable process of getting software done, consisting of 5 phases: requirements, design, implementation, verification, and maintenance. The waterfall model succeeded in imparting rigor into software development. A lot of rigor. Yeah. A lack of flexibility, late-stage testing, resistance to change or adaptation, and typically very long development cycles resulted in missed deadlines and high risks of total project failure. The lumbering inflexibility of projects that adopted the waterfall model resulted in the development of Agile. Next up, Agile. Yeah, this should be fun, right? An ideal for ideal circumstances. By the way, I will be poking fun at some things, and as you'll see, a lot of times things start off well, don't always go well, morph into something else, so don't throw things at me, please. Please, at least not till later. Anyway. But Agile was an ideal for ideal circumstances. The Agile Manifesto was a short set of general principles that were penned by absolutely brilliant people as a guide to reducing the friction surrounding software development in every way possible. Did you catch that? general principles. So here's the entirety of the Agile Manifesto. Yeah, see if I can read that on my tiny screen here. We are uncovering better ways of developing software by doing it and helping others do it. Through this work, we've come to value individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. That is, while there is value in the items on the right, we value the items on the left more. Seems pretty general, right? It was meant to be general principles. Is anyone here familiar with Jeet Kune Do, the martial arts philosophy of Bruce Lee? Anyone? Bueller? Okay, not so much. Okay, well, anyway. Jeet Kune Do is to martial arts as Agile is to development methodologies. So to summarize, Jeet Kune Do is not to be confined to a single set of techniques or forms, instead emphasizing adaptability and utilizing whatever action is most effective in a given situation, essentially fighting without a fixed fighting style, making it a fluid and responsive approach to combat. Just as aspiring martial artists did with Jeet Kune Do, developers, managers, CIOs, and CTOs read the Agile Manifesto and said, collectively, can you be a little more specific? A little more prescriptive, maybe? We need steps. We need guidance. We need a process. And just like that, Agile became a lot less agile. If there's one constant in life, it might be this. And yes, I actually did quote myself on this. I say this all the time, and I also typically follow that up with, good thing we're not people, right? There were long debates of what constituted big A Agile, the formal stuff, with little a Agile, the stuff that we all like, right? But once the marketing folks and salespeople and consultants got hold of it, things took a pretty dramatic, costly turn. Agile folks fought the term methodology, but once enough ceremony was in place, that's pretty much what it was. Did it work? At times, yes. At times, no. Hold that thought. Yes, all right. One of the more well-known Agile methodologies was extreme programming, or XP for short. XP was born in an era of good intentions, massive developer hiring, and ZIRP, zero interest rate policy, otherwise known as free money. Who doesn't love free money, right? The case that two heads are better than one has numerous stated benefits to back it up, and most are well accepted, at least in principle. At least in principle. Sorry, I stepped away from the mic. Knowledge shared, mistakes caught earlier, quality improvement, and so much more. There were downsides too, as with all things. One keyboard, one monitor, one mouse. The workstation was shared with two people. One developer drove, the other one acted as a helper brain, and periodically they would switch roles. Code quality, yeah, this is a live look at XP in practice, right? Code quality might be better, often was. Code quantity might be less, often was, when you combine the output of the combined team versus two separate. Maybe half as much, maybe less if every function, every decision was discussed prior to, during, and after the code was laid down. Some other side effects, if you will. When one person was sick, had a doctor or dentist appointment, or just took vacation time, the remaining half of that two-person team was sometimes adrift. For XP shops, there wasn't a programmer's lounge full of hot swappable spares who could tag in and immediately be useful. Some of those shops recognized the issue, and as a result, actively discouraged developers from taking time off, even when sick. I mean, who could have seen that coming, right? One other downside rarely discussed was the grind of being joined at the hip with another human being all day, every day. Even the best of relationships factor in some space. And some XP shops ran an idealized version of the XP playbook. Both this and the time off problem failed to accommodate critical human factors and were responsible for innumerable cases of initially enthusiastic embracers of XP becoming burnt out XP refugees. Another human foible is to assume that if some is good, more is better in every case, right? With that, the concept of mob programming was born. What could possibly go wrong? Whew. 2 people to a workstation? That's amateur. Let's have the entire team share one keyboard, mouse, and monitor. Crazy, right? As you might imagine, mob programming collapsed under its own weight. Nothing more to say about that one, really. Rest in peace. However, did any good come of XP? Well, most of us, from time to time, pair, right? That's a useful construct. And some in our industry and others have long had a check my work philosophy as well, where you have peer reviews and code reviews. That could be considered a way of getting that second set of eyes and improving code quality, reducing bugs, and sharing some of the knowledge among devs that the philosophy driving XP actually helped foster. Yes, yes. The moniker serverless brought with it confusion, increased difficulty teasing out right-sized functions, and troubleshooting those functions when something inevitably went wrong. And the occasional billing challenge just to boot. Yeah, I hear painful laughing over here, so I feel your pain. Turns out that we didn't want to have endless existential discussions about whether or not any servers really were involved. 90% of what we wanted was just scale to 0. All right. Testing that boils down to is true equal to true costs developers more in time to run test suites and cognitive load every time tests change, and that developer has to wade through a bunch of no-value add substance-free unit tests. Like many well-intentioned goals, it turns out that adding space-filling tests just to hit a magic number can actually work against the goal of delivering higher quality software faster. Rigorous testing is here to stay, make no mistake. However, 100% test coverage is for the most part out. Choose your metrics more wisely. Oh boy, okay. Yeah, this is more of a mouthful, and I guess oop and fip. I like it, yeah. Sip, oop, and fip. Yes, let's do that. All right. So I list all 3 of these because we can debate what, if anything, comes next. But the fact is that each of these 3 went from an idea how to make developers' lives better and the it thing to being widely accepted as a reasonable or even preferred way of getting things done. Structured programming rescued developers from spaghetti code. Object-oriented programming made code more manageable and reusable with data and behavior safely encapsulated, controlled sharing, and with classes grouped into related lineages. Functional programming reduced unpredictability, which in today's world has much wider-ranging impacts in reality than times past, with immutability. Rather than outright replacing each other, these paradigms coexist and influence each other. If you stop and think about it, object-oriented programming borrowed ideas from structured programming, like modularity and control structures. Modern object-oriented programming languages integrate financial programming concepts. Some examples include Java streams and C++ lambdas. Functional languages often include object-oriented programming features. For example, Scala and F# allow object-oriented patterns. Today, many developers mix paradigms to get the best of all worlds. A few more language-specific examples. Java developers, any Java peeps out here? Yeah, all right, be noisy. It's okay. Use streams and lambdas, functional, alongside traditional classes, object-oriented programming. Python developers, anybody? Yay! 4 people, all right, no, I'm just kidding. Yay, all right, there you go. Use decorators and comprehensions, functional, but still rely on object-oriented programming structures. Even C++ has functional additions like standard function and lambda expressions. So, style. Lasting style, just not in ways that might have been obvious from the beginning. Polyglot. Come on, we got to do this, right? We're in this together. Frankly, Polyglot hasn't worked out the way at least most organizations claimed to begin with that it would, right? The promise of Polyglot was you'd support any number of languages and you'd just deploy them all and they'd be happily coexist, right? The problem is most companies have a very limited number of dev teams and they standardize on a relatively small selection of tools and languages. It's kind of a practicality matter more than anything. When you can't do everything, you look for efficiencies. Put more wood behind fewer arrows, as Steve Jobs famously quipped. Multi-cloud, yes. The ideal of multi-cloud support by organizations is born of a similar mindset as the ideal for polyglot, a simultaneous complete support for multiple options. Isn't that nice? So relaxing. While it's a bit more contained even in principle, after all, you're far more likely to support a dozen languages than a dozen different cloud providers. The overhead introduced even by supporting a couple of different cloud providers is substantial. Of course, it can be done, but even with cloud management tooling that supports a higher level of abstraction, there is still a lot of cloud specificity that can creep in, even in the most anodyne of use cases. To be clear, the original multi-cloud vision didn't mean that an organization would use different clouds for different applications or systems. What it meant was that every system could and should, or in the original vision, be ready to run on 2+ clouds at any given point in time. And the monster motivating this vision was the dreaded lock-in. Yeah, we're back to multi-cloud. Yeah, I just had to get the cool pictures in there. Of course, most of us press against the edges of our primary platform's capabilities. And it's especially in those areas, those edge cases, that features and implementations differ the most between different cloud providers. So in most cases, immediate fiscal realities, money, overwhelm the idea of enterprise-wide multi-cloud support, and usually other less expensive provider-specific mitigations are found. Yeah, this is a fun one. For the purposes of this section, we're going to pass over the mainframes and mini computers that ran all the logic on a centralized unit and used dumb terminals. We're going to start with more or less distributed computing here. So yeah, keep your eye on the ball. Try not to hurt your neck. Here we go. So it began with the so-called fat clients. All logic of any import ran locally on the client machine. Anybody remember fat clients? Yeah, a few people willing to fess up. Yeah, those were great times, and they were the best of times, they were the worst of times, right? Yeah. So all logic of any import ran locally on the client machine. Fat clients were hard to deploy and hard to maintain, and were more client machine architecture specific, generally speaking. Even though they could be very powerful, the fat clients could, thin clients rapidly supplanted them with the thin client's ease of distribution and updates. To update your thin client, the user literally just had to do a browser refresh, and then you had the latest app. Nearly all logic was done server-side at this point, right? You'd craft and send the UI from the server to the browser, the client browser. This seemed like a great idea, but having all of the logic on the server, thin clients suffered from full page reloads, high server loads, bandwidth issues, and limited interactivity. They managed to struggle on both front and back ends. Awesome. So building up the local browser UI and more, often using JavaScript, led to single-page apps. SPAs were more dynamic, but performance issues and developer complexity, state, hydration, API calls, and more could be pain points. Of late, server-side rendering, sometimes called server-side logic execution, is pushing back on the move back to the client. Sort of. It's more of a hybrid approach, really, that enables leveraging CDNs to push static content, speeding up the initial page loads, and smoothing overall performance until the next thing comes along. The Internet of Things. Any big believers, any big advocates, anybody who lived through those heady times? Yes, oh yeah, good stuff. The Internet of Things was the hot topic for a few years. Developer conferences had separate days for it. There were even developer conferences specifically dedicated to the Internet of Things. I remember being asked at one of these events if it would last. And I said at the time that if IoT had any value at all, and clearly it did, that eventually incorporating edge devices into a systems architecture would result in it being fully integrated into the systems architecture. In short, IoT wasn't a fad, only the hype surrounding its novelty. Edge computing, as it's now called, was here to stay. My response sadly wasn't uniquely prescient, although I'm happy to say it seems to have panned out. Yeah, I got a lot more response on that one. Yeah. Anybody have the scars to prove it? Yeah. All right, well. Remember when microservices were the solution to every problem? You could probably go to your doctor with like a headache and you get prescribed microservices. So to understand why, let's examine a little history. What preceded microservices? The monolith, of course, the big ball of mud. The famous big ball of mud. One massive, can't even talk. Whew. Call somebody, I need another mouth. One massive, messy ball of spaghetti code. Hard to test, hard to deploy, and hard to scale. The identified problems were real, and many of those problems were either caused directly or were enabled by dumping everything your enterprise depended on into a single code base, stirring, baking, and then building your enterprise around it. Again, what could go wrong? The idea of breaking down monolithic applications into smaller independent services was revolutionary. Honestly, it really was. It promised greater scalability, flexibility, and ease of maintenance. And in many ways, it succeeded wildly. There was only one tiny problem. Every architecture has its trade-offs, and nuance isn't a strong suit of the hype machine. Microservices do offer granularity, scalability, and a lot of other illities, as I like to say, but they require more complex orchestration and robust monitoring than a monolith would, right? Because after all, it's not really hard to orchestrate a single giant monolith. I mean, it's one thing, right? And running microservices at scale can lead to increased latency and difficulties identifying, isolating, and resolving issues. With the successes and setbacks of a growing number of microservice implementations, there is a maturing of thought, I'm happy to report, on when to lean into them and when to apply similar modular thinking to building a better monolith. The style remains for both. One interesting side note, even architectures aren't immune to the if some is good, more must be better mindset. While microservice architectures were capturing most developers' imaginations, some clever influencers attempted to coin and justify even more diminutive naming in architectural divisions. Anyone ever hear of nanoservices or picoservices? Nope, and you likely never will again. Blockchain. You knew this would make the list, right? So what about blockchain? It burst onto the scene with the promise of decentralization, security, and transparency. Unless you're Satoshi, of course. Wow, okay, I really thought that would actually get a bigger laugh. Kind of hurt here, if I'm honest. While blockchain has found success in certain applications like cryptocurrency, as hinted above, and supply chain management, it's a technology, not a panacea. To date, blockchain projects have struggled with scalability, regulatory issues, and practical implementation challenges. As a result, much of the initial hype has, thankfully, died down, and we're seeing a more measured and realistic approach to blockchain as a technology. The fad appears to be morphing into a lasting style, with as yet mostly untapped use cases. The promise of no code and low code is seductive. The idea that people with little or no coding experience can roll their own solutions. But it's been here before. Anyone remember RAD tools? Rapid Application Development? Well, I'm kind of dating myself here a little bit, I guess. I mean, I love history, but I also lived through that one, so that's a whew. No code and low code just keeps coming back, changing the name to protect the innocent. So there must be something to it, right? Yeah, right. No code, low code works. Sometimes, and I kind of lump them together, but similar birds of a similar feather, I guess. And it works. They work sometimes. And for some of those times, when it works, it's enough, or it's more than enough. Many times, though, requirements expand. Has anybody ever had a set of requirements that never expanded? See me afterward, if anyone ever has. I'm still looking for that person. So the problem is, almost inevitably, now that we can do X, we know we need to do Y. And sometimes the person excited about that no-code, low-code tooling, when they find this out and they find out that their tooling may not support it, here's where they land. The pit of despair. Oh, sorry. No, sorry. The trough of disillusionment. So close. Similar idea. But don't count no-code and low-code out just yet. This is one area that can benefit a lot from another of our new developments, and that is It's here, it's there, it's really everywhere. AI, right? So if you thought the blockchain hype machine was loud, the one for AI is deafening. Really? Truly? Yeah, it is. That doesn't mean it's wrong, though. I doubt there's a single person on the planet who would disagree with the statement that AI is grossly overhyped in some very, very wrong ways. AI is an amazing tool that, as a general concept, obsoletes itself nearly daily. Ever see a car or an airplane go by so fast that you just see a blur? Well, imagine that happens on repeat, and each time the blur gets even harder to see. That's how quickly the state of AI is improving. Now let's assume that AI is here to stay, and it is, make no mistake, but in what areas? As was the case with the Internet of Things, nearly all isn't an entirely wrong answer. It will just become less buzzy over time and more ever-present where it makes sense to be as time goes on. Some questionable, maybe, you be the final judge, visions of AI that have been stated fairly recently are, chatbots taking over all UIs. Talk to the computer for every interaction is unlikely to be the primary means of user interface, AI or not, for the foreseeable future. Ever hear people shouting at their Ray-Bans in a crowded public place? Isn't that nice? Ever had voice recognition convert a fairly pedestrian request into, whoa, what is that? Okay. I think we're good, yeah. So that will improve and use will increase. But as with many previously discussed developments, it's good to have options and optimize for circumstances. AI-generated code replacing senior developers. There's been a lot of noise about this lately. It's possible, eventually, maybe. But remember that we were all promised flying cars, and we're still waiting for those. I don't know who I need to speak with about that. Because it's easier to make promises than to deliver on them. Breakthroughs as initially envisioned almost never evolve the way expected. For now, coding assistants and other AI tools are force multipliers, great helpers that go beyond the search engines. The coding sites, Usenix, IRC, Slack, Discord, Reddit, whatever channels or groups might have been present and might be present now. Current AI tools are increasingly valuable aids to engineers speccing, building, and documenting systems to satisfy functional and non-functional requirements, many of which are less than perfectly defined. Who knew, right? In short, AI offerings are absolutely amazing enablers. Are they disruptive? Without a doubt, and at times, jarringly so. But on balance, the expectation and the hope is that AI will be a huge net positive. This one is here to stay. So, in conclusion, you know what, I think it's important to be open to new technologies, but to be aware. And I think as a way of summarizing this very quickly, let me just skip to the next slide and share with you my take on the serenity prayer for technology. Grant me the serenity to endure the tech fads, the courage to embrace the lasting and evolving tech styles, and remaining unswayed by the hype, the wisdom to fairly evaluate them all to determine the difference. Thank you.